For millennia we have gazed at the stars and wondered, are we alone? Could there be other worlds out there teeming with life as vibrant and diverse as our own? Today, our gaze extends beyond mere curiosity. We dream of reaching out, of touching the face of other worlds and perhaps even calling them home. But space, as we know, is a harsh mistress. It's a cold, unforgiving void, where even the simplest necessities like breathable air and fertile soil are luxuries beyond measure. How do we transform these alien landscapes into havens for humankind? The answer might lie in the humble kingdom of fungi. As we stand on the precipice of a new era, fungi are emerging as vital partners in our journey. When we think of life, we often picture lush forests, vibrant coral reefs, or majestic savanna creatures. But beneath our feet lies a hidden world, the fungal kingdom. Fungi belong to a kingdom all their own, with unique biology and roles. They are decomposers, recycling nutrients back into the ecosystem. Fungi transform waste into fertile ground for new life. They construct vast underground networks called hyphae. These networks facilitate nutrient exchange, crucial for ecosystem health. Imagine a world where waste is not an end product, but a valuable resource, constantly being transformed into something new and useful. This is the promise of fungi in the realm of bioremediation, the process of using living organisms to clean up pollutants and restore balance to contaminated environments. Fungi possess an uncanny ability to break down a wide range of substances, including some of the most harmful pollutants that plague our planet. From heavy metals and pesticides to industrial waste and even plastic, fungi have shown remarkable potential in detoxifying our environment. How do they do it? Fungi secrete powerful enzymes that can break down complex molecules into simpler, less harmful substances. This process, known as biodegradation, is a natural and sustainable way to remediate contaminated soil, water, and air. This ability to transform waste into resources makes fungi ideal candidates for closed-loop systems, where resources are constantly recycled and reused. And in the confines of a spacecraft or a Martian habitat, where every atom counts, such closed-loop systems are not just desirable, they are essential for long-term survival. Building structures in space is a daunting challenge. Transporting heavy materials from Earth is incredibly expensive, and the harsh conditions of space pose significant engineering hurdles. What if we could grow our habitats instead? This is where fungi offer a truly radical solution. Remember those mycelial networks, those intricate structures woven by fungal hyphae? Scientists are now exploring the potential of using these networks as a building material, a kind of self-growing, self-repairing bioconcrete. The process begins by mixing fungal spores with a substrate, like agricultural waste. The fungi colonize the substrate, their hyphae growing and intertwining, binding the material together into a solid, lightweight structure. The resulting material, often called mycocrete, is surprisingly strong and durable, with excellent insulation properties. Imagine growing habitats on the Moon or Mars, using locally sourced materials, and a little help from our fungal friends. This isn't science fiction, it's an active area of research, with prototypes already demonstrating the feasibility of this revolutionary technology. One of the biggest challenges of living on the Moon or Mars is the lack of a breathable atmosphere. We need oxygen to survive, and transporting it from Earth is simply not sustainable in the long run. Enter, once again, the remarkable world of fungi. Some species of fungi, known as photosynthetic fungi, have formed unique symbiotic relationships with algae. These fungi provide shelter and nutrients to the algae, while the algae, in return, produce oxygen through photosynthesis. Scientists are now exploring the potential of using these photosynthetic fungi to create bioregenerative life support systems for space habitats. These systems would mimic the natural cycles of Earth, with fungi and algae working in tandem to recycle waste, purify air, and generate breathable oxygen. Imagine living in a space habitat where the very walls breathe, where waste is transformed into resources, and where the air is constantly replenished by the silent work of these microscopic partners. This is the promise of bioregenerative life support systems, and fungi are poised to play a crucial role in making this vision a reality. As we venture further into space, we leave behind a trail of debris, defunct satellites, spent rocket stages, and fragments from collisions, all posing a growing threat to future missions and even to our planet. Cleaning up this cosmic junkyard is a monumental task, but fungi might offer a surprising solution. Some fungal species have shown an appetite for metals, even those found in spacecraft components. These metallotolerant fungi absorb and accumulate metals within their cells, effectively biomining these valuable resources from space debris. While still in its early stages, this research holds immense potential. Imagine using fungi to not only clean up our space environment but also to extract valuable metals from asteroids and other celestial bodies, providing us with resources for future space exploration. This is the beauty of bioremediation with fungi. It's sustainable, efficient, and can be deployed in environments where traditional methods are impractical or impossible. Growing food in space is another major hurdle we need to overcome. Traditional agriculture requires fertile soil, plenty of water, and sunlight, resources that are scarce on the Moon or Mars. Fungi, however, can thrive on a variety of substrates, including agricultural waste, and require far less water and light than traditional crops. This makes them ideal candidates for space farming, providing a sustainable source of protein and nutrients for astronauts. Mushrooms, in particular, are incredibly efficient at converting substrate into edible biomass. They are also packed with essential nutrients including protein, vitamins, and minerals, making them a valuable addition to the astronaut's diet. Imagine biting into a juicy shiitake mushroom grown in a Martian greenhouse, a testament to the ingenuity of life and our ability to adapt and thrive in the most challenging environments. Section 8. Shielding ourselves with mushrooms. Space is a dangerous place, bombarded by cosmic radiation and solar flares that pose significant risks to human health. Finding effective ways to shield ourselves from this radiation is crucial for long-duration space missions. Surprisingly, fungi might hold the answer once again. Certain species of fungi, particularly those found in extreme environments like Chernobyl, exhibit remarkable radiation resistance. These fungi contain melanin, the same pigment that protects our skin from the sun, but in far greater quantities. Scientists are now studying these radiotrophic fungi, exploring their potential to create bioshields that can absorb and deflect harmful radiation. Imagine spacecraft hulls coated with a layer of radiation-absorbing fungi, providing a natural and renewable shield for astronauts on their journey through the cosmos. This is just one example of how the unique biology of fungi can be harnessed to address the challenges of space exploration, offering innovative solutions that might seem like science fiction but are rooted in sound science. Section 9. Fungi, the unexpected astronauts. Fungi have already journeyed into space, hitching rides on spacecraft and even spending time on the International Space Station. These fungal pioneers are helping scientists understand how these organisms adapt to the unique challenges of microgravity and cosmic radiation. Experiments have shown that some fungal species grow differently in space, their hyphae forming unique patterns and structures. These findings provide valuable insights into the fundamental biology of fungi and could lead to new applications here on Earth, such as developing novel biomaterials or improving agricultural practices. These early spacefaring fungi are paving the way for more ambitious missions in the future. Scientists are now planning experiments to test the feasibility of growing fungi on the Moon and Mars, taking the first steps towards establishing a fungal presence beyond Earth. Section 10. Challenges on the path to a mycelium future. While the potential of fungi for space exploration is vast, there are still many challenges to overcome. We need to develop efficient and reliable methods for cultivating fungi in space, ensuring they have the right nutrients, temperature, and humidity to thrive. We also need to address the potential risks associated with introducing fungi into extraterrestrial environments. Planetary protection protocols are essential to prevent any unintended consequences for potential native life forms or the delicate balance of these alien ecosystems. Despite these challenges, the potential benefits of harnessing fungi for space exploration are too great to ignore. With continued research and innovation, fungi could become our indispensable partners in our quest to explore the cosmos and establish a sustainable human presence beyond Earth. Section 11. A future filled with fungi. Imagine a future where fungal bioreactors hum quietly aboard spacecraft, recycling waste and generating oxygen. Picture lunar outposts with walls grown from mycelium, bathed in the soft glow of bioluminescent fungi. Envision astronauts on Mars harvesting fresh mushrooms from a vertical farm, their meals supplemented by the bounty of these versatile organisms. This is the future that fungi could help us build, a future where we live in harmony with nature, even as we venture beyond our home planet. It's a future where the seemingly insignificant organisms we often overlook hold the key to unlocking our potential as a spacefaring species. As we stand on the brink of this new era of exploration, one thing is clear: the future of space exploration might be more fungal than we ever imagined.